Welcome, everyone. We're so excited to have you here today for this webinar on the future of soil bulk density measurement systems. This is a special collaboration between Medusa Radiometrics, based in the Netherlands, and Berkeley Nucleonics, headquartered right here in the USA. Together, we're bringing you cutting-edge innovations that are reshaping how we measure and understand soil density. Medusa Radiometrics, based in Holland, has been leading the charge in developing advanced soil measurement technologies like the RhoC. Their expertise in gamma spectroscopy and innovative sensor systems has paved the way for more efficient, precise, and accessible solutions. So here in the United States, Berkeley Nucleonics is proud to partner with Medusa to bring these advancements directly to you. So with our locations in California and New York, we're perfectly positioned to support customers across the country. So whether you're working in agriculture, construction, or soil research, our team here is ready to ensure you have access to these groundbreaking tools, along with the training and support you need to maximize their potential. So today's webinar is all about exploring this exciting partnership and showing you how these innovations can make a difference in your work. So we're here to answer your questions, share insights, and spark ideas. So thank you again for joining us. Let's get to it. Let's dive right in. All right, so we're going to start off with a poll question for everyone here. First poll question of the webinar: do you currently use or have you used a soil bulk density measurement system in the past? So have you used one? Are you looking to use one? Have you just done it the old-fashioned way? Please take the time to answer this first poll question. All right, let's talk about our incredible partner, Medusa Radiometrics, based in Holland. They are a leading provider of geophysical survey equipment. So they're known for their innovative and user-friendly solutions that make survey work easier and more efficient. Medusa focuses on creating reliable, straightforward tools so professionals can spend more time on their work in the field and less time worrying about keeping their sensors up and running. So Medusa specializes in developing cutting-edge equipment that measures naturally occurring radiation in soils by using radionuclides as proxies. So their systems can uncover valuable insights such as correlations with soil parameters. So this makes their technology incredibly versatile, with applications in pollution mapping, sediment mapping, mineral exploration, and much, much more. What makes Medusa stand out is their real commitment to simplicity and accessibility. They combine intuitive equipment with in-house developed software to help professionals collect and analyze data with ease. So it's all about empowering users to focus on what they do best. So delivering high quality geophysical surveys. So Medusa also takes pride in measuring their success by the satisfaction of their customers. They're really committed to providing reliable products, excellent customer support, and building long-lasting relationships across the world. By listening to customer feedback and staying ahead of industry advancements, Medusa has established itself as a real leader in geophysical survey technology. So now, through our partnership here with Berkeley Nucleonics, we're thrilled to bring Medusa's groundbreaking technology to the US. With our support network in California and New York, we're here to help US customers access these tools and provide the guidance and service needed to make their work even more efficient and impactful. Need for density measurement. So soil compaction is one of those challenges that really sneaks up on you. In regions like the Netherlands and other parts of Europe, it's become a major issue, especially with heavy machinery used during harvesting in wet conditions. So picture this: these machines put so much pressure on the soil that they create a compacted layer, almost like a crust, where plants just can't grow effectively. So the roots can't push through, and water and nutrients really struggle to penetrate. So over time, this reduces crop yield, and it really affects soil health. So it creates a ripple effect on farming productivity. So this very problem is what inspired the development of the RHOC. The name itself is meaningful. It's RHO for density and C for concentration, the RhoC or the RHOC. So it's designed to make measuring soil density straightforward and accessible, helping farmers identify and address compaction issues before they really get out of hand. But it's not just a European problem. We know soil compaction is also a significant issue here in North America, especially with the increasing use of large machinery on farmland. The wet conditions combined with frequent traffic across fields can quietly degrade the soil structure. And the thing is, most farmers don't realize the long-term consequences until the damage is done. That's why awareness is so important. So farmers need to know how compaction affects their fields, and more importantly, how tools like the RHOC can help them measure and monitor soil density quickly and accurately. So it's not just about solving the problem, it's about empowering farmers to make better decisions for their land, their crops, and their future. All right, so let's take a moment to talk about how soil density has traditionally been measured. One common method involves Kopecky Rings. So these are small, around 100 milliliter cylinders that are carefully inserted into the soil. The soil inside is then scraped off, dried, and weighed to calculate density. So while this is considered a standard approach, it's very hands-on and time-consuming. For something as simple as measuring soil density, it can feel like more of a chore than it needs to be. Another method is digging profile pits, which involves analyzing different layers of soil by excavating sections of the field. This method can give you some useful insights, but it does require a lot of manual labor. And again, it takes a significant amount of time. And then there's the penetrometer. So this tool is designed to measure soil resistance by being pushed into the ground. But here's the thing, it really depends on the strength of the person using it and the moisture level of the soil at the time. So if the soil is too wet, the readings can be inconsistent. And if the person operating it isn't consistent with the force applied, the results may not be reliable. So the takeaway here is that while these conventional methods have their place, there are far more efficient or foolproof methods now. So again, these do require time, effort, and in some cases, a bit of guesswork. That's exactly why we need better tools to make this process faster and more accurate and easier for everyone involved. So tools like the RHOC 5 are designed to address these challenges and make soil density measurements something farmers can do quickly and confidently. So, next slide. So measuring soil density is one of those tasks that shouldn't be complicated, right? It's something that needs to be done often and accurately. So making it easy and accessible is key. That's what Medusa set out to achieve. They developed an innovative solution that takes the guesswork and hassle out of the process. Instead of relying on time-consuming, labor-intensive methods, this new approach simplifies soil density measurements, allowing you to get reliable results much, much faster. But again, speed isn't the only thing that matters. Data precision is equally important. Medusa's solution is designed to not only save time, but also deliver highly accurate data. So let's face it, when it comes to making decisions about soil health, crop planting, or land management, you need that precision to make informed decisions. So what Medusa has done is create a tool that hits all the marks. It's fast, easy to use, and gives you the accurate information you need without the complexity of some of these traditional methods. So it's a game changer for anyone. Okay, we have another poll question for the audience. Another poll question, please. Again, we always love to hear your feedback. We like to get some of these questions, compare. We don't know. So next poll question, what is a key requirement for your soil bulk density measuring? So what is a key requirement for you, whether you're in construction, whether you're doing soil analysis, whether it's for research, what is your key requirement? Let's take a closer look at how the Medusa RhoC works. So the key component here is actually a small gamma source, specifically sodium-22. It's important to note that this source is exempt from regulatory restrictions. So it's making it safe and practical to use in the field. So when the gamma radiation is emitted, the amount that's reflected back correlates directly with the density of the soil. So this measurement provides what we call the field bulk density, which includes soil, water, and air. But the RhoC doesn't stop there. It also calculates the dry bulk density, which separates the soil and air components. And on top of that, the device is equipped with a depth sensor, GPS, and moisture sensor, so to accurately determine the water content. So these features work together to give you a complete picture of soil conditions. In practice, the process is very straightforward. So you take readings at regular intervals, typically every 5 to 10 centimeters, and the device records the data. What you end up with is a detailed plot like the one shown here. On the x-axis, you have the dry bulk density, and on the y-axis is the depth. So this allows you to visualize how the soil density measures as you move deeper into the ground, so providing very critical insights that are invaluable for managing health, soil health, and making informed decisions. So with its ease of use and precise measurements, the RhoC takes the complexity out of soil density analysis, and it really brings modern and efficiency solution to the field. So it's really remarkable what Medusa is doing with the RhoC. So let's take a quick look at what comes with the Medusa RhoC. We're going to show you a quick video here. Hello everyone, today we're going to do the unpacking of the RhoC soil density and moisture meter. Came all the way from the Netherlands and Holland. We're going to show you what's inside. So when you purchase your system and it gets delivered, this is exactly what you'll receive, a very ruggedized Pelican case, and with everything that you need to operate the system. So we're gonna open it up and just go over all the items in there. So
first and foremost, you'll see the RhoC 5, the MS RhoC 5. Very light. It's a very light system. Again, soil, moisture, and bulk density. Right here is the cesium iodide detector and all the components that will allow you to do bulk and soil density. All right, after that, you're going to get the plastic base plate. So the plastic base plate to attach, to include it in here. And then you can tighten this up, and depending on the depth that you want to keep going, you can tighten it, and then it'll be stable once you're surveying. So you'd be like this, and then you stabilize it. Next on your list is going to be your specifically chosen auger to drill holes before you begin your analysis. So this will come with the system. Do your holes in here, and then after that, you get your hammer. So with this, for this hammer, you'll be able to make your holes for when you want to do your analysis, right? Next on our unpacking list is the smartphone. So this system is all operated via the smartphone. So come with the smartphone. All the software is already pre-installed, so you're good to go on that. Everything that you need to operate the system will be in there with the ruggedized case, and then with the phone holder. So the phone holder will simply attach to the system here, and then you'll be able to operate the RhoC 5 via the smartphone. And then the power cables for you to charge your RhoC 5. These are the charging cables. This is the LEMO. And then lastly, you'll have your GPS stubby. You'll have the GPS, and then that, again, you'll be able to connect right here, your GPS. So pretty straightforward, extremely lightweight system. It's been used in Europe for many years now. For the first time ever, we're going to be having it here in the US. So any questions, any additional information you might need, let us know. But the RhoC 5 is now available here in the US for you and your colleagues. Thank you.
All right, so that was a quick video, kind of again going over what you will get when we ship and deliver your RhoC 5. Here's a nice overview of the actual interface, the GUI of the RhoC 5. It's all operated on a PDA. The app is already pre-installed. You connect it via Wi-Fi. You turn it on, and then you can see the projects, the settings. You could export files, and then the measurements, which will include, like we discussed, the moisture, the depth, and all the information that you need for bulk density measurements. And all of them will be in there. And then you could see that there's also the battery of the system and the depth, and also GPS. Also very, very valuable information when you're doing your measurements. All right, next slide. All right, let's take a look at this video of a student actually using the RhoC 5. So as you can see, the process is quick and efficient. In just about 15 minutes, he was able to take all the measurements needed directly in the field. So this is one of the biggest advantages of the RhoC 5. It streamlines the entire process without compromising accuracy. So now let's compare that to the traditional method with the Kopecky Rings. So after finishing the with the RhoC 5, the student moved on to take measurements using the Kopecky Rings. So this method, as many of you know, It involves carefully inserting the rings, collecting soil samples, drying them, weighing them. So in this case, it took him about half a day just to complete the field measurements before he even got to the laboratory for further analysis. So the contrast is clear. The RhoC significantly reduces the time and effort needed to measure soil density. So not only does it save very valuable time, but it also allows for quick and reliable data collection, making it, like I said, it's a game changer for anyone dealing with soil analysis. So with tools like this, you can focus more on applying the data than spending hours or even days gathering it. So very nice video. I love this one. Really kind of opened me up to how quick and efficient the system is. All right, let's dive into how we validated the RhoC. So to test the reliability, we placed the sensor in two different fields, one with loam and the other with sand. So across these fields, we conducted a total of about 180 measurements using both the RhoC and then the traditional Kopecky ring method. So each field had 10 soil pits, providing solid data set to compare the two approaches. So now if you look up at the graph on the right, you'll see the depth plotted on the y-axis and the field bulk density on the x-axis. So each point represents the average of the three measurements with the error bars showing the standard deviation. So this gives us a clear picture of the consistency and variability of the results. So what's interesting is that while there are some minor variations between the RhoC and the Kopecky rings, the overall values align closely. So the consistency demonstrates that the RhoC ability to provide reliable measurements is comparable to the standard Kopecky method, but with far less time and effort. So in essence, this validation highlights the RhoC as a highly dependable tool for soil density measurements, offering accuracy and efficiency that traditional methods simply can't match. All right, so here's how we validated the RhoC against the traditional Kopecky rings. So we compared the dry bulk density values from the Kopecky rings, which are plotted on the x-axis, with those obtained using the RhoC plotted on the y-axis. So as you can see from the graph, the values align very closely, showing strong agreement between the two methods. This alignment demonstrates that the RhoC provides measurements that are consistent and widely accepted to the standard of the Kopecky rings. So to further quantify the comparison, we calculated the RMSE error for both test fields. So for the loam field, the RMSE error was 0.12 grams per cubic centimeter. And for the sand field, it was 0.14 grams per cubic centimeter. So these results are well within an acceptable range that show that the RhoC can reliably match the precision of traditional methods. So, but however, interpreting RMSE values can sometimes be a bit tricky. So to help clarify this further, we've taken it a step deeper in the next slide, where we compare the Kopecky rings with each other. So this will give you a better sense of the variability within the standard method itself and how the RhoC measures up to it. So let's go to the next slide. Here we are. So let's take a moment to talk about how we compared the Kopecky rings with one another. In the graph here, we analyzed measurements from three profiles. So we compared profile 1 to profile 2, profile 2 to profile 3, and finally profile 1 to profile 3. So these comparisons allowed us to assess the consistency of the Kopecky ring method itself, which again is widely regarded as the gold standard in soil science. What we found was reassuring. The data points across the profiles were consistent, and when we calculated the root mean square error, it came out to 0.14 grams per cubic centimeter. So this result shows a very strong correlation, confirming the reliability of the Kopecky ring measurements. So now the Kopecky ring method has been trusted by soil scientists for years now, so because of its accuracy. So essentially, the benchmark for validating new methods is the Kopecky rings. So if you want to learn more, you can find in-depth information actually published. The title of the paper is Validation of a New Soil Bulk Density Sensor in Agriculture and Geophysics, which demonstrates that the RhoC5 is not only on par with this trusted method, but also brings significant innovation to the table. So with the RhoC5, we're looking at a modern, reliable tool that matches the accuracy of the traditional approach while being far more efficient. So it's a huge step forward in soil analysis, giving researchers and practitioners a faster and equally dependable alternative. Let me just reiterate how much of a game changer this is. So with the RhoC5, you can now measure 3 profiles in about 15 minutes. So think about that. What used to take half a day with the traditional Kopecky ring method is now done at a fraction of the time. And like we said, it's not just about the speed. The quality of the measurements remain on par with the trusted Kopecky ring method. So you're still getting the same reliable data, but in a much more efficient and streamlined way. What's even more impressive is the range of data you can collect in the short amount of time. So the RhoC5 gives you field bulk density, dry bulk density, depth measurements, and even GPS measured data all in one go. So this efficiency isn't just about saving time, it's about making soil density analysis more accessible, practical, and even effective for scientists, farmers, and land managers. So it's tools like this that make modern soil science so exciting, especially here in the US, in regions like California, Iowa, Texas, where agriculture, soil, farm, land is so important for here in the US and worldwide, wherever we have partners and good business. So let's take a closer look at where the RhoC5 is making a difference. So originally, the focus was on agriculture. It was a pioneer, game changer for analyzing soil organic carbon levels and assessing soil health. So 2 things that are crucial for sustainable farming practices and land management. But what's exciting is how the RhoC5 is finding its ways into other areas like construction. In construction, understanding the integrity of the soil is absolutely essential. So whether it's for building foundations, roads, or large infrastructure projects, having reliable soil density data ensures the safety and longevity of work. So here in the US, we're seeing growing interest in places like Oregon, California, and Texas. So these states are leaders in agriculture and construction, and they're home to some of the best universities in the world like UC Davis and Texas A&M. So these institutes are not just teaching the next generation of soil scientists, but also advancing research in sustainable agriculture and geotechnical engineering. So the RhoC5 has the potential to make a huge impact here. So imagine how tools like this can help researchers and professionals get accurate results much faster freeing them up to focus on solving bigger problems. So as the word spreads and more people see the benefits, we're really excited to see how the RhoC 5 continues to grow in popularity and applications across the industries.